Okay, I'm going to make a short video here to talk about selector switches, and I'll also talk about some diagrams and different types of logic. So here's a selector switch. It's a two-position selector switch. Okay, right here the green contact block is normally open contact. You can see the gap there. Okay. Let me turn the switch, and now you can see that the gap is gone. Okay, so now it's closed. Look at the numbering on this green contact. 23, 24. So we'll come in on 23 and we'll go out on 24. So let's look at the closed side. I know it's a little hard to see because of the wording on there. Let me turn the switch off. And you can see that it's a little hard to see, but right there, I don't know if you can see the contact. It's touching that metal part. That's terminal number 11, 11 and 12. Okay. Let me turn on the switch. And you can see it move. So normally closed contact is going to open when I turn on the switch. Normally open contact is going to close. So this is a toggle switch. It's a selector switch. It's got a maintain position, one open and one closed contact. So let's look at some of the symbols that we'll be using. Let me focus a little bit. Okay, so this is a ladder, a control diagram, relay control diagram. And notice on the left side I have 24 volts. On the right side I've got negative. Okay, this is DC, 24 volts DC. Notice on the left side I've got numbers 1. Let me get my pen here. 1, 2, 3, 4, 5, 6, 7 on the left side. These are the line numbers or the rung numbers, like rungs on a ladder. It looks kind of like a ladder. So let's talk about all these numbers here. This is an open switch, S1. Come in on 23, go out on 24. These numbers tell me how to connect the wires to the switch. Okay, if you don't put those numbers there, it's not a problem. We should go in on the low number, go out on the high number. But it's always better to add as much information as you can. Okay, so here's wire number 1, wire number 2, wire number 0 on the negative side. And a lot of times the negative side will be color-coded. Maybe it's a white conductor, maybe it's white with a blue line on it, a blue tracer. Maybe it's black, you know, it just depends on the colors you're using. For 24 volts, a lot of times we like to use blue on this side, white and blue on this side. So we may not even number these wires because it's white and blue. We know that's the return side on the 24 volts. Okay, so here on this first line, this is just an on-off circuit. It's off right now. If I close the switch, light turns on. Okay, rung number 2, I have 2 switches. If I turn both of them on, pilot light 2, PL2 turns on. This is AND logic, this and that. Okay, down here, switch 4 and 5, this is OR logic. This one turns on, or this one turns on. Pilot light 3 lights up. Okay, notice the wire numbers, they're getting larger. 1, 2, 3, 4, 5. Okay, 1 is always on the left, 0 is always on the right. The numbers in the middle change. The numbers change every time I go through a switch. Okay, so 3, 4, 5. This is 5 here, and this is also 5 down here. Okay, so let's look at number 5. Notice I put a 4 right here on this one. You know, it can go either way. I've seen it drawn different ways on different diagrams. if I call all of this line 3, it's a little hard to know if I'm referring to this top one or the bottom branch here. So let's just call it 3 and 4, okay? Down here on 5, this is not logic. If I do not turn on switch number 6, pilot light 4 is on. So here's wire number 6. This is the 11-12 connection, okay? So down here on row number 7, or number 6 here, what do you think this would be right here? If 7 is on and 8 is not on, so this is combinational logic. You know, when we're talking about motor controls, what we're really talking about is two different things. One is, you know, how do I make the motor spin with a starter or a contactor, something like that. But the other part is the logic that goes into making it operate correctly. Okay? So now we're getting into logic, different types of logic. We have and, we have or, we have not, we have combinational logic. And this one here is the most complex of all. What do you think this might do here? If I turn on switch 9, what would happen? Power would go through this switch, it would go through this switch, and the light would turn on. So if I turn that off and turn on switch 10, power goes through this one. When I turn the switch off, it's going to go through switch 9 because this will open. Okay? So when I see the dotted lines, that's telling me that these two contacts are tied together. I only have one switch number 10, so if I close this one, I open this one. So let's go back through that again. If switch 9 is closed, the current goes this way. It does not go down here because this is open, so it goes across the top. If I open that switch and close this one, the current goes across the bottom pathway because this is open. So if I turn both of them on, these both open and the light cannot turn on. This is a special type of logic called exclusive OR logic. This or that, but not both. So, you know, when we're talking about digital logic in the electronic world, in the old days we had integrated circuits that would generate each type of logic, and, or, not, exclusive, or, you name it, there was a chip that would do that. And we can literally do the same thing with switches here. If we take this one step further and put control relays here instead of indicator lights, then the control relay has contacts that can be used to do the same sort of thing, different types of logic. Okay, so when we talk about relay logic, we're talking about using relay contacts to make simple combinational logic decisions. Now this type of logic is kind of reacts. You know, if the switch turns on or off, the output turns on or off. It doesn't have any memory, but it's very simple to take a control relay and add a seal-in circuit that will give it memory so it stays on. We call that 3-wire control logic. And I'll draw a diagram here in another video that will show 3-wire control logic and how it has memory and how it can be used to turn things on and off without using a selector switch. Okay, so these switches, these are all selectors. You turn them on and they stay on until you turn them off. And that's fine if that's what I'm after, but imagine this situation. Let's say I turn on power on switch 1, and let's say this is actually a motor, like a mixing motor, okay? And then the power fails, and the power comes back on, the mixer starts immediately. Well, now that might not be a bad thing, but imagine if the power turns on and off very quickly, 50 times, the mixer motor will probably burn out because it's not designed to switch on and off very quickly. So this simple maintained switch logic might be okay for some things, like maybe a lighting system, you know, like, well, that's what your wall switch is. Your light switch is a snap switch, on and off. But for other things like motors, it's not a great choice because of that problem of power cycling on and off. So the next video will show 3-wire control logic, which uses momentary push buttons instead, and gives us an automatic reset function. So I'll show you that in the next video.